Scientists are planning to build a giant biovault on the moon. But why the moon? And what is this vault for? This ambitious project aims to safeguard Earth's biodiversity from catastrophic events by storing frozen samples of crucial species. Why do we need a lunar biovault? Life on Earth has faced many threats over millions of years. Think about it, asteroids, volcanic eruptions, and ice ages have all pushed life to the brink. Now, in our modern world, climate change has become an even bigger threat. According to scientists at the Intergovernmental Panel on Climate Change, IPCC, if we don't slow down global warming, nearly 1 in 5 species on land could become extinct by the year 2100. That's a huge loss for our planet, and it's why some scientists believe we need a backup plan, a biovault on the moon. Our oceans are in trouble too. It's not just life on land that's in danger. Our oceans are in crisis as well. Dr. Mary Hagedorn, a marine biologist who studies coral reefs, is one of the scientists on the front lines of this battle. She works at the Smithsonian's National Zoo, where she's trying to save coral by freezing their sperm cells and larvae. By storing them in liquid nitrogen, she hopes these samples can be brought back to life in the future, helping to restore damaged coral reefs. Connecting the dots. From coral reefs to the moon. With all these environmental challenges, Dr. Hagedorn and other scientists are thinking big, really big. They propose building a vault on the moon to store frozen cells from species that are crucial for rebuilding our ecosystems. We already have a seed vault in Svalbard, Norway, which stores over 1 million types of seeds at -18 degrees Celsius. But when it comes to freezing live cells, we need much colder temperatures, below -196 degrees Celsius, which we can achieve using liquid nitrogen. Here on Earth, keeping things that cold requires a lot of energy, but on the moon, it might be easier. Why the moon? So, why choose the moon? The moon offers some unique benefits. There are places near the lunar South Pole that are permanently shadowed, meaning they're always in the dark and super cold, perfect for cryopreserving or freezing these vital cells. Some ancient lava tubes on the moon are also incredibly cold, which might work for storing these samples. However, the moon does have a big downside. It has no magnetic field, so it's exposed to dangerous radiation from space. To keep the samples safe, Dr. Hagedorn suggests burying the vault at least 2 meters below the lunar surface. What kind of cells will be stored? Now that we've covered the location, let's talk about what will be stored in this vault. Dr. Hagedorn's plan starts with something called fibroblast cells. These cells are like the building blocks that support and protect our organs. They can be easily taken from skin samples and reprogrammed into stem cells, which can then turn into different types of cells. This makes fibroblast cells perfect for cloning and preserving species. But that's not all. The team also plans to include reproductive cells like eggs and sperm to make sure there's enough genetic diversity for future generations. Testing the concept in space. Before we can build the vault on the moon, we need to make sure this idea will actually work. That's why testing it in space is the next step. Dr. Hagedorn thinks that low Earth orbit, where the International Space Station, ISS, is located, is the perfect place to start. Experiments on the ISS have already shown that turning fibroblast cells into stem cells is easier in microgravity, which is the condition of very low gravity found in space. This supports the idea that we could freeze and store these cells in space, and later bring them back to life. Dr. Hagedorn hopes her team can start testing this process on the ISS within the next 5 years. First steps. Testing with a small fish. As we get closer to making this lunar vault a reality, the first tests are crucial. The team has chosen a small reef fish called the starry goby for their initial trials. In 2023, they collected 10 of these fish from Kaneohe Bay in Hawaii and froze 2 pelvic fins from each fish to test different packaging types. Now, they're waiting to see if they can send these samples on Griffin 1. a private mission to the Moon's South Pole, which could happen as early as 2025. Choosing which species to store. If the initial tests go well, the next big question is, which species should be stored in the lunar vault? Dr. Hagedorn emphasizes that the goal isn't just to save endangered species. It's also about preserving the functions of Earth's ecosystems. This means storing species that are essential for rebuilding environments, like worms and oysters, which help clean the ecosystem, primary producers like algae and plants, and pollinators like bees. These organisms are crucial for keeping ecosystems healthy and could play key roles in restoring life on Earth in the future. Thank you for joining us on this journey to explore the ambitious plan to create a lunar biovault. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into the future of science and space exploration. Stay curious, and we'll see you in the next video.